Okay, we are going to get ready to solve quadratic equations by graphing. And in order to solve a quadratic equation by graphing, you need to know how to graph a quadratic equation. If we look at a example of a quadratic equation, step number one, there's a couple steps that you're going to do that, to solve it by graphing. So step number one is to set the equation equal to 0. And right now, the equation is equal to 3. So how are we going to get rid of that 3? We're probably going to subtract 3 from both sides. And when we subtract 3 from both sides, this is what we get. X squared minus 4x plus 3 is equal to 0. And you get plus 3 because 6 minus 3 is 3. And you get 0 because 3 minus 3 is 0. So this is what we have. So that's step number one. We have it set equal to 0, have the equation set equal to 0. And we need to do that because in step 2, we're going to, instead of 0 now, we're going to put a y in there. We're going to put a y in there. And this is important because 0 equals y, or backwards, y equals 0. And wherever y is equal to 0, that's going to be our solution. That's going to be our answers. And step number 3 says, actually I'm ahead of myself. Step number 2 said sketch the graph. We don't have a graph yet. So let me get a graph on here for you. There we go. There's a graph. And so if you're looking there, it says sketch the graph of the function. Well, we have a quadratic equation graph there. And step number 3, the answer are the x, I put that on 2 lines, but the x-intercepts, or when y equals 0, and that's the concept. If you look there, because we took out 0 and put in y, what we're trying to do is we're trying to figure out where this quadratic equation is equal to y when y is equal to 0. Well, when y is equal to 0, isn't it right here at these points? And those points would be called the x-intercepts. The x-intercept here is 1, 0, and the other one is 3, 0. We're going to make a little note here. It says the answer. The answer has a few different names. When you solve a quadratic equation like this, sometimes it'll be called you're finding the roots of the function, or you're finding the zeros of the function, or maybe even the solutions. So in this quadratic equation, the roots are going to be 3 and 1. You put a comma between it. Don't put a parentheses around it. If you put a parentheses around it, it looks like an ordered pair. Or you can just say 3 and 1 are the answers. So that means when y is equal to 0, x will be 3, and x will also be 1. This quadratic function has 2 answers, has 2 roots, has 2 solutions, has 2 zeros to it. And some of the questions that you'll be asked will ask you to find, all 3 types of answers: roots, zeros, solutions. So what you have to do is you have to know how to graph a quadratic function, and where it crosses the x-axis is going to be the answer there. So let's move along. Let's do a couple of these. This first one says we're going to solve 2x squared plus 6x is equal to negative 4. Step number 1 says we got to have 0. We got to have it equal to 0. So let's add 4 to both sides. Now, 6x plus 4, we cannot do that because they are not like terms. So we have 2x squared plus 6x plus 4 is equal to 0. Now we actually need to sketch the graph of the function when y is equal to 0. So we need to sketch the graph right here. y equals 2x squared plus 6x plus 4. Well, you know this is a quadratic function, so we need to find the vertex. X is equal to negative b over 2a. 6 is b, 2 is a, and 4 is going to be c. So we have negative 6 over 4, and this is equal to negative 3 over 2. And since x is equal to negative 3 over 2, we're going to plug it into the equation and calculate what y is. So we have 2. We're going to have negative 3 over 2 squared plus 6 times negative 3 over 2 plus 4. And that's equal to y. Work this out. You're going to have 2, and this is going to be equal to 9 over 4. Negative 3 halves squared is 9 over 4. And 6 times negative 3 over 2 is going to be a negative 9 plus 4. And go ahead and multiply 2 times 9 over 4. I can cancel the 2 out, and the 4 reduces to a 2, so we have 9 over 2. So now we have 9 over 2 minus 9 becomes a fraction with a denominator of 2, so we have to multiply 9 by 2. And 4 does the same thing. 4 is going to be 8 over 2. And so let's add all these numbers up. 9 minus 18 will give you negative 9, and negative 9 plus 8 will give you a negative 1. That's equal to y. So that's going to be our vertex. Our vertex is going to be negative 3 halves, and our y value of that is negative 1 1/2. So we graph that. Negative 3 halves means you go left 1 1/2, and negative 1/2 is down 1 1/2. So there's the point. Negative 3 halves, negative half. And we need to go ahead and graph the rest of the function. I know since a is positive that it's going to open up. So and here's what the parabola should look like. We are off a little bit there, and it looks something like this, or rounded off here at the bottom. And now, what are the answers? What are the roots? What are the zeros? When y is equal to 0, so let's look here. When y is equal to 0, that's going to be the x-intercepts, and it's those points right there. I believe the right one is going to be negative 1, 0, and the left one is going to be negative 2, 0. So your answers are going to be negative 2 and negative 1. Those are the roots of the function. Okay, that's the first one. The second one here, we do the same thing. We notice we get lucky here because it already says it's equal to 0. So what we need to do is we need to graph the function negative x squared plus 7x minus 10 is equal to y. We need to graph that function. So first off, find the vertex. X is equal to negative b, because here we have a x squared plus bx plus c. So negative b over top of 2a. Well, 2, what is a? A is going to be the negative 1. It's the invisible 1 there. And that's just negative 7 over negative 2, which is equal to a positive 7/2. Well, in that case, if that's a positive 7/2, let's go ahead and plug it back into the function. Plug it back into here. So we're going to have negative, and x is 7/2. We're squaring that. We're going to say plus 7 times 7/2 minus 10. And that's going to be equal to y. And so if we go ahead and work some of this out, 7/2 squared, 7 squared is 49, 2 squared is 4, and drop down the negative sign with it. On the next one, we have 7 over 1 times 7 over 2. Well, we know positive times a positive is a positive, and multiply the top numbers. 7 times 7 get multiplied to give you 49, and on the bottom, 1 times 2 get multiplied to give you 2. And then we're going to subtract 10, and that's equal to y. So now let's go ahead and do some getting common denominators the same. We have denominators of 4, 2, and 1. So 4, 2, and 1, 4 is going to be the common denominator. If you have to multiply 2 by 2 to get 4, you have to multiply 49 by 2 to make an equivalent fraction. 98 over 4 will reduce to 49 over 2. And 10, if we have 10 over 1, so we need to multiply the 1 by 4 to get 4, and so you have to multiply the 10 by 4 also, and you get 40. And so that's what we're looking at. And let's go ahead and add some of these numbers together. Negative 49, let me get a different color here. Negative 49 plus 98 is a 49. And then we minus 40 from it. That's going to give us 9. And that would be a positive 9. And on the bottom, we have 4. So y is equal to 4. Let me erase some of my scratch work there. So y is equal to 9 over 4. And that's a positive 9 over 4. And so our vertex, x was 7/2 and y 9/4. So 7/2, 9/4. So 7/2 is approximately 3.5, right? So we're going to go ahead and graph that. We go over to 3.5. And now 9/4 is 2.25. So that means we go up 2 1/4. Something like that. And so that's our vertex, that green dot that I have there. Right there. We have a vertex now. Now we need to calculate the rest of the graph. If you probably want to pick some x values, plug them in, solve for y, and then you can plot the graph. Remember that a quadratic function is symmetric, so whatever you get on one side of the line of symmetry, it should be symmetric to the other side. So let's look here. We're going to go ahead and graph this. I know since a is a negative value, it opens down. So I can go ahead and plot these points. I can plot these points. And that's what it should look like. And so now that you have it graphed, um, you look up here, where is y equal to 0? Y is equal to 0 here, and y is equal to 0 there. These ones fall perfect on those numbers because that ordered pair is 2, 0, and the next ordered pair is 5, 0. So we have answers. We have roots of this equation. The roots are going to be 2 and 5. Those are the zeros of the function, 2 and 5. And let's look at one more here. Actually, let's have you try this one. You try this one on your own, and then check your solution with mine. Go ahead and pause the video and see what you can do. Well, if we look at what we have to do, we have to get this set equal to 0, so we're going to add 20 to both sides. So we're going to have negative x squared plus x plus 20 is equal to 0. Now we need to graph the function that is the same, but instead we're going to put y in for 0. So let's go ahead and do this. Let's go ahead and find the vertex. The vertex is negative b, so vertex is negative 1 over 2 times negative 1. And this reduces to, I know 2 times negative 1 is negative 2, and I know negative divided by negative equals a positive 1/2. So if that's the x value, the y value, plug it into this function here. So we're going to say negative x is 1/2 squared plus 1/2 plus 20, and that's going to be equal to y. So if we go from here, now we just need to go ahead and work this out and solve it. We know 1/2 squared, that's 1/2 times 1/2. 1/2 times 1/2, multiply the top numbers, you should get 1/4. Drop down your negative sign with it. Okay, so if we have negative 1/4, and we're going to add 1/2 to it, negative 1/4, and you add 1/2 to it. Well, I know 1/2 has to have a denominator of 4, so I'm going to go ahead and make that switch to 2 over 4. 2 over 4 will reduce to 1/2. And since we have 20 over 1, we're going to go ahead and make it with a denominator of 4. So I had to multiply the 1 by 4 to get 4, and then so I should also multiply the 20 by 4 to get 80. So now let's go ahead and see what we have here. What we have here is going to be negative 1 plus 2, which is a positive 1 plus 80. So that's 81 over 4. 81 over 4 is the y value. Okay, so now where do we go from here? We have an x value of 1/2. We have a y value of 81 over 4. So this is our vertex. We need to plot this. Well, we know 81 over 4 is going to be 20.25, and that's not going to fit on our graph. 20.25, and that's not going to fit on this graph. So, what can we do? Well, I know a way to make it fit on this graph. I know this graph has the x and y axis labeled for you already, but I'm not interested in using that as the x and y axis. I want to go ahead and use the y axis here. This is still going to be the y axis. Okay, y axis. And then I'm going to change, and I'm going to make this down here at the very bottom. I'll make that down at the very bottom the x axis. And the reason for that is now I should have 20 numbers all the way to the top. 20 numbers all the way to the top. So now I can graph 1/2 and 81 over 4. So 1/2 is halfway over. 81 over 4 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 1/4. Let me get rid of some of this for you. 20 and 1/4. So approximately right here. Approximately right there. So now, if we're looking, we can go ahead and graph. We can graph the quadratic, the parabola here. So let's go ahead and do that. I know it's a negative. A is negative, so it's going to open down. So we need to go ahead and, since this is symmetric, we will put them on the other side of the line of symmetry. And now let's go ahead and graph this. I know that's not perfect, but it's close enough, and it's about as close as I think we're going to get by freehanding it. If we use graphing calculators or computer programs, they will be exact, and they will make it exact. So let's look here. Let's find our answers. Our answers, remember, are where y is equal to 0. And a lot of you might think that that right there is the answer, but remember we changed our x-axis so that way we could plot the vertex on the graph. Remember, our new x-axis is right here and right there. So we need to figure out what those x-intercepts, what those zeros are, or what those roots are, what those solutions are. So if we're looking 1, 2, 3, 4, 5, so 5, 0 is that x-intercept. And 1, 2, 3, 4. Negative 4, 0 is that intercept. So therefore, our answers are going to be negative 4 and 5. And you have solved that quadratic function by graphing. That's all we have for today. So appreciate you stopping by to listen. If you have any questions, make sure you don't hesitate to ask.